Hi guys, and welcome to our second video for geometry questions. So last video we covered questions 1 through 4 in this review. In this review now today we're going to cover questions 5 through 8. As some of you may know, geometry questions are around roughly 15 to 18 questions of the exam. The exam is exactly 60 questions for the math section of the ACT. It varies. Every exam, it may not be exactly 15 or exactly 18 out of 60, but you can anticipate roughly 20 to 25% of the questions are geometry specific questions. So it's definitely valuable to go over the concepts and the formulas. In today's review, we're going to cover circle, we're going to cover formulas for triangles, perimeter, midpoint formula, Pythagorean theorem, distance formula. So without further ado, let's get started. The first question, question 5, is asking for the radius of circle M. Here we have a circle. This has an arc of 30 degrees, and it's represented by the value 8. Now, some of you may recall that a circle has 360 degrees all the way around. So in this case, we're going to set it up as a proportion. So 30 degrees here out of 360 degrees is equal to 8 over c, which represents our circumference. The formula for circumference is 2 times pi times our radius r. We just use these symbols pi and r for shorthand instead of writing them out. If you were to write pi on your calculator, it's an irrational number, meaning that it doesn't end and it's very long. Some people actually memorize all the units of pi, but it keeps going. Some people just memorize 3.14 as the abbreviated version of pi. But if you want an exact answer, you need to plug it into your calculator as pi. Okay, now we want to solve for the circumference. We don't know what it is right now. We just have this proportion, this ratio. So like with any variable, when we set it up in this way, we're going to solve for c by cross multiplying. So we're going to do 30 times c, 8 times 360. And if you do that on your calculator, it'll be 8 times 360. That's 2,880. And then 30 times c is just 30c. So we're going to divide this by 30. And this is the value of c. Our circumference is 96. So c is equal to 96. But that's not what this question is asking us for. Specifically, they want to know what is the radius. So we're going to use the formula for the circumference, now that we know its value, to solve for the radius. So we're going to say 96 is equal to 2 pi r. We're going to get rid of our variables here to isolate pi. So first, let's do 2 and pi. 2 pi. You could do it individually first 2, then pi, but for the sake of time, we're just going to do this all together. So this will cancel, then you're left with just the radius on one side. And 96, divided by 2 is equal to 48. Then if you divide that by pi, you have to do the blue button and then pi. You get 15.27. Let's take a look at our answer choices. Do we have that? Well, yes, we do. And this, we're just going to round it. Anytime your decimal is 5 or above, you can round up the value. So 7 will round to 8 because of the item next door, which is 5 or above. In this case, it's 8. So 8 rounds up 7 to 8. So we have 15.28 is the answer for 5. Okay, let's take a look at question 6. This is asking us for the area of triangle ABC. Now notice this entire triangle is ABD. We only want to know the area of this one, ABC. So like with all triangle formulas, we just want to write them out so we can keep track. So the area of a triangle is equal to 1/2 times our base times our height. A lot of people abbreviate this and they just do 1/2 times b times h. And that's the formula we need to keep track of. Now the base is just the bottom of this triangle, right? It's 7 and 5. So 7 and 5, if we're looking at the entire base of the triangle, is here. Obviously we can do this in our head, but just for illustration, it's 12, right? So this whole thing is 12. My height is already provided. This right here is my height, 12 also. So let's plug it into the formula. We're going to do 1/2 times 12 times 12. For those of you who have memorized this, 12 times 12 is 144. 144 divided by 2, which is the same thing as multiplying by 0.5. That gives us an area of 72. So that's this entire triangle, right? That would be like when I highlighted it earlier, this. So that's the area of the entire triangle, what we just solved. But I want to know this interior one. So I'm going to have to subtract it from this smaller triangle over here. So let's take a look at the base and the height of this one. So 1/2 times our base of 5 times 12. So if you memorize 5 times 12 is 60, half of it is 30. So that's the area of this smaller triangle. We're going to subtract 72 from 30 to find the area of this triangle right here, which is what we're after. That gives us 42. Let's take a look at our answer choices. Do we see 42? Ah, yes. Choice A. Okay, moving on. Question 7. Question 7 at first glance seems kind of intimidating because it's like this shape that we can't really define, right? It's not a polygon, it's not a triangle, it's not a circle, and we're trying to figure out its perimeter. But we are given certain pieces of information. We know that this segment here to here is 10. Well, if you look at the shape, you notice that we have a bunch of those. So we can count them out. So we have 10 here. This is another 10 here. It skips. We have a 10 here, 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 and keep going. All right. So if we count that out, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 tens. So if we're trying to figure out the perimeter, which is just, it's like the circumference of a circle. It's like the area around the shape. So 12 times 10, 120. But that's not the full area, or sorry, the circumference, of this shape. We want to know these slanted pieces here, what those are. Now, for those of you who remember from the prior video what an isosceles triangle is all about, where we have two side lengths that are exactly the same, here and here. Let me do that again so you can see what I highlighted. Okay, what that means is that two sides of the isosceles triangle are always the same length, whatever they are. So in the last video, it was 5 and 5. In this case, we have 10 and 10. And in the last video, remember, we had 5 root 2 as our hypotenuse, which is always the longest side. So in this case, it's going to be 10 root 2. You may ask yourself, well, how did I know that this side right here, this hypotenuse, is 10 root 2? Well, it's just the property of an isosceles triangle. When you notice that two sides are exactly the same length, the hypotenuse has to be x root 2. So it came from this model, x root 2. In this case, x was 10. We got that from here. So if you were to divide this into a triangle right here, this would be 10, this would be 10, this would be 10 root 2. So because we're solving for perimeter, we're just going to add up all the sides. I already know that I have 2 of these diagonal here. So it's 10 root 2, that's 20, right? Root 2. So the only answer that fits that is D. We have 120 from multiplying 12 times 10. And we have two sides that are 10 root 2, so therefore 20 root 2 is our answer. Finally, on this page, we have Question 8, asking for, in triangle ABC, what is the length of the median segment AM? Anytime you have a bar above, we call this a segment. So here they have drawn the segment for us, which is super convenient. A median, like the name sounds, cuts through the middle of this triangle. And we're trying to figure out specifically what is the length of this median that's highlighted, this segment AM. So we want to use the midpoint formula here. This comes up in every ACT, so you want to memorize this. The midpoint formula we are going to, it's very simple, we're going to add the x values, divide by 2, and add the y values, divide by 2. So it's x1 plus x2, all divided by 2, y1 plus y2, all divided by 2, and then in parentheses, okay? So what that's going to look like is, in this case, 2 plus 8, that came from here and here, 2 and 8. So obviously 2 plus 8 is 10. 10 divided by 2 is 5. We'll simplify in a second. Then we're going to do the y values. So that would be here and here, 4 and 2. Okay, so 4 and 2, well, let me just simplify it. It's just 6, right? And then 6 divided by 2 is 3. I'm just jumping ahead here. So let's just simplify this. This is just 5, 3. This is my midpoint. This is the middle point between B and C. Now, I need this middle point in order to do the distance from A to M. That's what I'm trying to figure out. I'm trying to figure out the distance, aka the length of this median AM. So the second formula we're going to use is the distance formula, which also, coincidentally, always shows up on the ACT. So the distance formula, we're going to do the difference of, so let me write it out and I'll explain it. So 4 minus 5 squared plus 10 minus 3 squared. This, if we write this all out, this simplifies to the square root of 50, which is 5 root 2. That's the answer for B, because that is the length, aka the distance that we're trying to solve. But this comes from the distance formula, which is really just the difference of our x values squared plus the difference of our y values squared, all under the radical sign, the square root sign. So definitely, if you're not comfortable with this formula, you want to review the distance formula. But notice in question 8, we use both the midpoint and the distance formula. So these are really crucial to review. To recap, not only did we use those formulas, we reviewed isosceles triangles, what does it mean to find the perimeter, the distance around a shape. We reviewed the area of a triangle, 1/2 base times height. We reviewed circumference formula, 2 times pi times r. And we solve for the circumference to go and then solve for the radius, kind of backtracked. And we do this a lot in math problems, where we find one variable to use it to find another. So I hope you found this review helpful, and I'll see you at the next video. Thank you.